Alright, DraftScience video presentation, comments mostly, and then maybe we'll play a PBS video or do something, see how the time goes and such. Robert Ritchie, regarding a previous commenter who used this line, as above, so below, as below, so above, apparently is some poetry from the lost whatever crap of Atlantis or some other kind of crap, and so whatever, yes, it's just all, again, people's agenda. They want to convert reality into a fable. And there's a ton of these people that have these motivations, creationists and phantasmagoricals, people who have some kind of perception that the human race has some destiny as some kind of spiritual being thing. Yeah, some kind of crap. Anyway, so I won't bother reading the whole comment, but yes, thank you for pointing it out. I feared he wasn't being original. Yeah, okay. Anyway, I always wondered, James began, so this, I don't want to have to keep qualifying who commenters are, but interesting fellow, but he has this thing about how climate change is some sort of conspiracy by whatever the conspirers would be, but whatever, people who just hate technology or something like that, I don't know. Anyway, I always wondered how Einstein determined c squared. He could just as well have said c3, 4, and who would know the difference? Well, it's even easier when the E can be in Einstein's, right? Energy in the form of Einstein's, and then you just make an Einstein equal to so many newtons, and then you don't have a problem at all. But all the constants are really just there for one purpose, is to make things convertible into other things. In a sense, Einstein was the first to use E as meaning something. So again, it would be an in basically an Einstein quantity of his choice. But yes, he should have just left it a proportional statement, because we really can't say for certain that all of the mass of the atom is actually usable energy. That is, you can actually get the energy out of it, quote unquote, in the sense that the energy trapped in an atom is different than the energy that the bits themselves might possess innately. But whatever. It's close enough that it doesn't matter, but yes. I guess that's all we all should say. It's close enough that it doesn't matter. But anyway, so I don't know who this Roger Cook is. Cook? Anyway, thanks, same. It's got a weird icon, so for that alone, I'll just get rid of this. Yes, haha, fuck yeah, you're a funny guy. Okay, well, whatever. You're kind of funny looking, but just just saying. Yeah, it's just kind of a weird icon. Sorry, just a little too much face, and too smiley, like sinister smiles. So anyway, but thanks, I suppose. All right. So this is off subject, but I'll read it. Humanity passed its peak of intelligence. Now it's going down, down, down. Well, I would agree, but I would agree that the problem is cultural, not genetic. So the difference is that people are raised by cartoons and nonsense and frivolous gibberish, where in the past reality sort of made people appreciate a book and the light to read it by. And we've lost all appreciation for that, and all appreciation for the idea of being knowledgeable. It's just not a competition anymore. In a sense, wit and cleverness and intelligence had a huge amount of value in the past, because it made the difference between life and death, and it just doesn't anymore. Intelligence just turned into something silly nerds do, And, it just doesn't have any hard relevance like it had when it made the difference between you losing your crop or your roof falling down. And, real things happen because of ignorance in the past. Ignorance would kill you in the past, and it won't kill you as quickly in the present. So there's just a lack of appreciation for, applying, absorbing information. In fact, it only reached the level it did in the West due to brutal natural selection. Well, I don't agree with that at all. I don't think it had anything to do with it. Obviously, power had a lot to do with how we evolved and how people achieved power, and then they just inherited the power. So obviously that's not very good evolutionarily. Obviously the Trumps aren't genetically superior people. If you think they are, you're kind of foolish. But anyway, yet as soon as you say anything about idiocracy, the SJWs, again, I'm for social justice, and I will war for it, frankly. So you can put me in that category if you wish. But I'm obviously not for some of the stupid things they're for. Obviously, as a club, they're pretty dumb. But I'm not for the other assholes on the other side, frankly. Give it all to the rich, lazy fucks. Yeah, that's not a meritocracy. Inheritance. Inheritance isn't merit. It isn't merit pay. In charge will shout Nazi. Well, again, if you think this is about genetics, I just think you're missing what's the substance of the problem, which is culture. It's always about the culture. So you want to make it racial, that's your business. I think it's really stupid. Because the amount of intelligence you need to be a decent human being is absolutely tiny. Okay? Doesn't take much at all. Not to be a liar, a manipulator, a cheater, a thief, a crook, a bum, dishonest, non-conscientious, all these things. Not trying to make things better rather than making things worse. It takes a tiny bit of intelligence to realize, oh, here I am on a planet, and I can make things better or I can make things worse. Which one will I choose? I mean, not a hard choice. Don't need much intelligence to figure it out. So, I don't need to go to your summary of any argument. It's off the subject. Again, if you're worried about being called a Nazi, then you must be talking about genetics. And if you're talking about genetics, you're an idiot, frankly. Because that's not the problem. It takes very little intelligence to be a decent human being. Very little. Okay. A productive one, or even a well-educated one, in the sense that you don't need genetic capacity. Okay, you just need to spend your time working on something useful rather than dancing or prancing. All right, Bob the Fly, stupid time code, but whatever. It has to do with the fact that there is a physical chain of cause and effect. It has nothing to do with information. So he's quoting me. Yes. It's just stupid. So now he's going to defend playing with this stupid information word. There's absolutely no reason to call events information. There's just no reason to do it. There's billions and billions of events, and I mean, right now this thing is boiling, so to speak. The atoms are moving all over the place. Little crystals of plastic, blah blah blah. Why call that information? It's just idiotic. The rules of how things interact seem to me to be one possible description of information. Well, if that's what you think information is, and especially in our definition of our culture, information usually has to do with understanding causes and effects, understanding how things function as principles. As in principle, I understand this battery. I don't understand it as information in the battery. That would be retarded. Every little atom bang into every little bit and every little piece of heat. Why would that be called information? Because it's all meaningless. The only information that's valuable or could have any kind of use is understanding it as a concept, understanding battery as a concept, and understanding the particular chemistry used for that particular kind of battery, lithium, and understanding how that functions. You don't understand it in detail. You don't understand it atom to atom. You understand it as a process. And the process is what you're recognizing and saying, here's a hunk of process. I can call it something and put it in a category and label it. It's not the information is an abstraction of the reality. And that's where it has value. It has value as an abstraction. It doesn't have value as information in the fact of it itself. So this is just such crap. It's certainly not, it's certainly the principle of the battery isn't what gets caught in the singularity of the black hole. I mean, this is just such garbage. Play this game. Again, clearly history is a fact. The fact is we have one history. Not many histories, we have one history. There's one history to every atom inside of me, every molecule, every electron, every proton. It all has a history. And that's a fact. But to sit there and say that there's information value in every single event that ever took place would be idiotic, because no supercomputer, no anything ever will be able to process every single bit of information. So it's stupid. It's just playing games. It's a silly game to play with verbs and language. It just breaks the meaning of words. It's like calling something a wave that isn't a wave, like a photon. Something that's going in a straight line. Oh, I'll call that a wave. It's stupid. It looks just like a torpedo, but I'll call it a wave. Maybe a semantic distinction. No, it's worse than that. It's just a game played to make it sound like it's something it's not. So it's not just semantics. It's propaganda. It's using words that aren't appropriate to the circumstance. It exaggerates. It's like when somebody, you can use the word to say, the truth was raped by that dissident asshole, and you could say it where it's actually the truth because he's committing such an egregious crime, or you can use it and make it sound like a tiny, tiny infraction was some horrible crime. I'm just saying, calling cause and effect information theory is just to try to make it sound something like it's more magical than it is. Alright, how are you defining information? Well, I'm clearly not defining it as every event that ever took place ever in the universe. I'm calling information understanding concepts, understanding functions, understanding principles, understanding the general rules, not specific. Seeing gravity specifically happen to each little event, each thing being affected by gravity, doesn't make me understand gravity. The understanding of gravity doesn't have anything to do with specific histories. It has to do with understanding how they all have something in common, all the histories. And so it's a new piece of abstract information that doesn't have any physical correlation except in my brain. The only place the information really exists is in my knowledge of it. Just whatever. Go ahead, play your pukey games. What can I say? You want to defend turning the words cause and effect into the word information? Go ahead and defend it, but it's just fucking wankery, in my opinion. Disgusting abuse of language. All right. So Douglas Leveson, who cares what the radar experiment will show? So he premises it with, it doesn't matter. So the truth doesn't matter. The facts don't matter. Clearly that's all he cares to say. We have our theory. We don't care what the facts are. Everyone knows you're going to lie about it. Well, I'm going to block you just for that, because, no, go ahead, quote my lies. I've got 1,000 videos. I haven't deleted any of them. Now, I've certainly made some mistakes and I made some errors, but you go ahead and find a lie and quote it, okay, fucking liar? So, I mean, you premise an argument with something that you have no evidence of. It's just outrageously offensive. And you think you have some right to do that. Well, you don't have any right to lie, you fucking cunt. Alright, and pretend you said there wouldn't be any double frequency. So again, where am I going to say there's not going to be any double frequency? Now, what I have pointed out is, yeah, you got to be a little bit sophisticated. So, alright, so this is the radar experiment. I did think of another way to do it. Alright, but what we're looking for is, so the simple idea is, and this is just a fact, and nobody can dispute this and be called rational, is that currently we can't detect, we don't have technology that can defeat the simple premise. So there's frequencies, okay? So just imagine there's 4 or 5 of these things and they're all the same distance apart, right? And so you have, in the radar experiment, you're basically sending 2 of these to the same location. And you're sending from different distances, which means their frequencies will overlap. All right. Now, the important thing is so when they're in phase, you can understand how, okay, the antenna has no problem. It's getting 2 of the same signals, which means really 4 times the amount of energy. But let's not quibble. I mean, when it's demodulated. But anyway, and so the idea is that when they're off frequency, you can see that now if they're a little bit out of phase, that's going to be a problem because that frequency isn't going to be, say if the total distance was 100 hertz, we'll just make up an easy number. Now obviously when they're overlapped a little bit, well, some of the frequency is going to be 1 hertz and some of the frequency of the smaller number would be, the bigger number is smaller, so by wavelength it would be 1,000. So that would be like 1,000 hertz there, and then it'll be like 90 hertz here. But 90 is not 100, you know. So it'd be broken. There'd only be one hunk of it, one little piece, and then there'd be a 10 hertz, and then 100 hertz, then 10 hertz. So obviously it's going to be only in one single location that you're going to have a consistent frequency. Okay, so that's important. Frequencies have to be consistent to be able to be received by our technology. It can't really receive broken frequencies. It needs it to be consistent for a certain length. Ray lengths are important. So you can understand that only in one tiny location is that frequency going to be 50, well, 200, 200, 200, 200, you know, instead of 100. So in only one location are you going to be able to receive the exact doubling of the frequency or halving of the wavelength. Yeah. Doubling of the frequency or halving of the wavelength. So you can understand that, right? Now, is that a lie argument? Or is that some kind of chicanery by me? Or I'm doing a catch-22 by just pointing out a physical fact? That the experiment isn't as simple as you'd like it to be? Oh, it's my fault. It's not as simple as you would like it to be. So, I mean, that's just such a rubbish pile of crap to say. Now, my point would be is that all these little hits will be counted by the antenna. So whether they come like this, whether they come like that, or whether they come overlapped, each hit, okay, does create electricity in the antenna. So if you can just detect the electricity, then you're safe. Then it doesn't matter how broken up it is, doesn't matter all that other crap. But that's the tricky part, is that the way radio receivers work is that they take advantage of how by frequencies being able to store their energy through resonance, by being trapped and creating reflections interior, which means that you can multiply the signal strength because you're hitting at the right time, so you keep adding energy to the signal in the sense of when you're trying to receive it. So it amplifies, and non-resident signals won't get amplified. So that's the only disadvantage. But I think it's overcomable. I've stated it so. I think it is receivable by sensitive enough equipment. So I think it is a doable experiment, and it can be proven. Now, another modification I thought of to the experiment. there's no reason to think this interference thing that happens, they claim this, whatever, this wave interference. So let's understand, in the photon experiment, it's single photons that are supposed to be interfering with themselves. Single electrons interfering with themselves. In these other experiments, all of a sudden now it's two different electrons or two different photons that are somehow supposed to be interfering with each other. Now, electrons you can hit into each other, as far as I know. You can hit electrons into electrons, but you can't hit photons into photons. Alright, so there's no evidence you can. So it breaks one of the rules of quantum mechanics, one of the concepts, one of the principles, that this is supposed to be something happening just between a single photon having itself converted into a wave function. So in the interferometer and in this radar experiment, all of a sudden we're given this, it's implied, they won't say it directly, but it's clearly implied, that two different photons interfere with each other. And we don't have a conceptual understanding of how that happens by principle. There's no Huygens involved, there's no Copenhagen, there's no many worlds, none of that stuff has taken place here. So they've created a whole new principle, and that for which we're given no explanation for why the principle isn't consistent. That is why in all these other photon experiments, especially with visible light, we can't make electromagnetic radiation bang off of itself or interfere with itself with individual different sources. We can't shoot two laser beams into each other and make the photons bang into each other. So it violates some fundamental principles. And he's claiming he's so sure of what the right answer is. And I'm saying, yeah, I think that the truth is right there to display to you. I've clearly pointed out that the mathematics for jamming is exactly the same as the mathematics for interference. And so if you're just a reasonable person, you should be saying, well, maybe they did make a mistake here. You know, maybe they're being fooled, because jamming would look exactly the same as wave interference, because it's exactly dependent on the same phase equation. And so instead of just conceding that, oh yeah, that they might have made a mistake, no, he does this slop. Alright, you will pretend you said there wouldn't be any double frequency. Again, so I have explained where the double happens. It's going to happen only at one location. And so, yes, you have to be both precise enough to get to that location, and then you have to have instruments sensitive enough to detect a very high frequency signal, you know, which is more demanding. The higher the frequency, the more demanding it is on the hardware. All along, assuming you even concede the results. So, again, just more nonsense. There's no experiment I haven't conceded. So again, show me the experiment I deny. Go ahead, show it to me. So show the experiment that I have been unfair to, or that I perverted the results of it. You're the ones who keep lying about experiments. You're the ones who haven't done experiments you claim have been done. You, for like Stern Gerlach, you don't even show the experiment. You show an animation of an experiment. I mean, it's all over the gravitational lensing stuff, all kinds of animations, very little real anything. What other? I mean, there's so many examples where you're the ones making the claims about what the results are based on a tiny shred of evidence. You're claiming all kinds of entanglements, all kinds of other stuff. You don't even know what polarization is, yet you claim polarization filters don't interfere with photons. I mean, you know, you're the ones way out of bounds when it comes to distorting the truth and perverting the history. So anyway, yeah. So a couple people responded, which I you know, almost wish you wouldn't respond to trolls, but whatever. Because, you know, I'm blocking the comment, so your comment's going to disappear, but it will be acknowledged. So Stephen Burrow, who's going to do the experiment eventually, you know, yeah, I hadn't heard from him in 3 or 4 weeks, so I figured something went wrong again. But apparently it's not a terrible crisis. He's just, get around to it. I think Gary may concede. No, I'm not going to concede anything until there's real evidence of something to concede. Again, there's no experiments I'm denying. I'm just denying that, when Ken Wheeler shoots a weak little laser at something, he's not proving anything. Okay, if I can do the experiment to a significantly high standard, unlike last time, and if the results are the same despite the improvements. Well, like I said, I have no doubt about what the results are going to be. But whatever. I think he would face the situation. Well, again, I mean, all this speculation, I don't know what to tell you. If you can show photons interfering with photons, go ahead. Good luck with that. I don't think that's what you'll show. So I don't think you're going to prove waves. I'm just saying, what do you want? I'm supposed to concede to this perfectly done experiment that excludes all possibility that the radiation is still there, and I'm saying no. But there are lots of ways to do it, as pointed out before. So if you do the face-to-face thing, that'll be a great experiment. Just move something in between two cones faced right at the receiver. A piece of metal. And just measure the energy. And that'll tell you so much right there. Well, anyway, so the second experiment I thought of was this wave interference shouldn't have anything to do with the polarization of the radar. So the interesting thing about these radar guns is that they do produce polarized energy. So there's no theory that says different polarized photons, the photons have to be the same polarization to interfere with each other, right? They have no reason to assume that. Certainly with interferometers and all this other stuff, they don't pretend to say it's all the same polarization of light or anything like that. So if you have the two guns polarized opposite, then you'll be able to detect the signal from the two guns independently as a receiver. And if you get no interference, then with the gun, with the receiver one polarization, then turn the receiver to the other polarization. And if you can detect no interference pattern, that is no on-off, well, that'll tell you that the energy is getting to those locations. That somehow, when they're oppositely polarized, they don't interfere with each other. So that at least it will narrow their theory and say that somehow now their theory is dependent on polarization. That radar can only interfere with each other when they're of the same polarization. So they'll have to put another qualifier on their theory. Alright. Either then or soon after. I mean, this is speculating on the fact that you think you're going to prove wave interference. It's just, I find it laughable. But go ahead and think that's what you're going to do. You may even consider my alternative explanation. Well, why would I? I'm sorry. I don't see any. I don't have any need for an explanation because I already know what photons are, and I already have I think a much more rational explanation for what polarization is. So, again, I think I'm the one who's. I don't see any flaw in my theory. So why should I be interested in some other theory? Frankly, but I don't think anyone is going to like my explanation. TBH. Well, I'm just saying I'm not looking for one. I'm not in doubt. I see the evidence as being completely confirming my understanding of the basic function. I've noticed people, again, I find a better explanation of what a magnet is. I have subject videos in a playlist. Go to the magnetism one and show me a better explanation of magnetism. Simpler or more complete. I've noticed people don't like other explanations. Well, I can always find easy flaws in them, so I'm just saying you can go ahead and suggest one, but most of them are almost obviously flawed. It would be naive of me to think anyone will regard mine as any better. You have to be kind of brave to tell the world a hypothesis you know they're gonna lambaste you for? Well, the whole point is that everybody's theory should be tested. So as much as I find the way people are testing my theory obnoxious and rude, I mean, I think it's just disgusting that they can't do it in any kind of civil manner. I mean, I'm really not running from argument. I'm really, go ahead, make an argument. Show me good evidence. But that's not what they're doing. You know, they're just making a huge claim on experiments they don't even understand how they work, and then they're saying to me, go ahead, you know, debunk an experiment that will take you at least 2 months to understand how it even works. I mean, obviously, I'm not going to do that. So I want to work on these fundamental experiments, the ones they've been lying about for years. You know, the whole idea of the Young experiment, as if Thomas Young's experiment was at all remarkable in the face of what Newton had done 150 years earlier. I mean, it's just an amazing perversion, okay, of historical fact to think that Young provided any insight whatsoever. But you have to be kind of stupid to die with it. Well, I certainly say you might as well suggest something, but again, if it's, you know, sometimes your fear is based on the fact that you have a lack of confidence also. That, oh yeah, well it kind of works, but doesn't quite work. So if you see flaws in your own theory, that's a little bit intimidating and inhibiting. Gary, I've just deleted my ridiculously long comment explaining the current situation. Well, more information is seldom a bad thing. Let's just say it is ongoing, and I have lots of new equipment to do it better now. Yeah, well, I don't know if this is... certainly good equipment is important. But, you know, the more I think about this, the more you need the right equipment, or the right... Like I said, I was thinking about photomultipliers. And in principle, they should have a pretty big range of energy that they could receive. You know, everywhere from X-rays to maybe even microwaves. So it's an open question whether a photomultiplier can detect, I think it clearly should be able to detect infrared radiation, and, you know, but whether it can detect microwaves is an open question. But that would be a huge advantage if it does. Because, you know, then obviously you could use that kind of a mechanism to detect the actual signal instead of the modulated sound on the signal. But I'm extraordinarily busy lately. Yeah, I know you had to go to a wedding and do this and do that. But anyway, lots of pressure. So it will be a fair while yet. Yeah, it's fine. Do what you have to do. I'm just saying... You know, sooner or later it's got to get done. I just mean if you're not going to get it done sometime in the next 6 months or something, well then maybe I should go and solicit somebody else to do it, because it just sits there as this open thing that people can ridicule me for, because somehow I'm evading. Anyway, so Robert Ritchie chimed in. Firstly, please explain how you get a double frequency from a single frequency source. Well, clearly because it's two guns in the experiment. So there's clearly two frequencies, and clearly they're at different distances from target locations. You know, not even distances. Okay, so now the frequencies overlap. So, from the two. And the question is, they say the two signals are interfering with each other, and I'm simply arguing that no, they're just overlapping, which means the antenna can't see them. The antenna just sees this. It doesn't see two of these. It sees this, and it can't receive this unless it's tuned to this. This is twice the frequency of this. There's no, oh, I might still be able to hear the signal. No, there's no chance, and that's jamming. So there's two viable explanations. I claim, well, they say that's viable, that there's interference, even though it's separate photons, or the explanation is jamming. And I'm saying the explanation is jamming. Alright, so, rude person, fuck off. Alright, you have absolutely no idea what you're talking about. So that's not even worth blocking. It's just too stupid. I mean, obviously you could quote somebody and say that. You know, again, these are from people who have no account, you know, no content. They're totally unaccountable. So you're making a claim, and yet you're backing it up with nothing. Just your fucking cunt opinion. You just don't see how rude that is. I mean, just how obnoxious that is. You think everybody's supposed to be impressed because Andrew Hanfield says you have absolutely no idea what you're talking about. No. Nobody should be impressed by that, should they? Would you want people to do that? Would you want people every time somebody... like, say if you had some kind of favorite person on the internet and some asshole just typed this crap, but they had a name that was like, super great person name. And everybody should listen to them, but a super great person says so. I mean, you're just so fucking stupid. Anyway. I have counter space in my kitchen. Well, I guess it's an acceptable joke. When people ask a question, please answer it without being condescending. Fuck you, I'm not condescending. People are obnoxious and rude, asshole. I mean, but I don't think I've ever been condescending to anybody who asked an honest question. Now, if you think you can show some example where I was just terribly harsh on somebody who was just being fair, fine. But, you know, people say things, you know, they watch 10% of one video and then want me to personally instruct them on the entire theory. You think that's fair? That I should have to personally instruct people based on the fact that they don't want to watch the videos that aren't personally addressing them? I mean, I have to personally tutor, but I should never give lectures. They don't have to listen to any of the lectures. They just go to the personal tutor. I mean, fuck that. We are not all at your level of understanding. Thanks. So again, I don't think this has anything to be at a level of understanding. I'm just saying there's no point in asking a bunch of questions when you've only watched, like I said, 40% of one video. I mean, it's just wasting my time, isn't it? And again, I have done at least the minor effort of putting the stuff in playlists. So if you're really curious and you want to get get the brief of it, I mean, I have start here videos and from the beginning kind of videos, and then I have subject videos. I mean, so if you want to understand, the information's there to get. But it's just, I'm sorry if you don't think I should think it incredibly arrogant of people to think I have nothing better to do than answer a bunch of questions they're going to ask, as if I never made any other videos, when there's 1,000 fucking videos on the channel. Yeah. Anyway, fuck you. Alright, so James McGinn again. So this guy is like really obsessed with water. But it is an interesting subject. That was an interesting comment about the gigantic elasticity of water. So yeah, you can compare it to lots of things. I mean, everything, how molecules combine has almost nothing to do with, when they say something like H2O, like there's an oxygen and 2 hydrogen. It doesn't really mean anything when it's molecular water. That is, when the water starts crystallizing, and everything's a kind of a crystal, even a liquid crystal, like when it's in a liquid form. It's always in some sort of geometric shape that the atoms attach to each other with. And so they're not really H2O anymore. When they're molecularly bound, that is sharing electrons, they're really like H4O2 or some, they're some other form. And those forms can have all kinds of geometry depending on how they attach to each other. Whether, like sides of a box, the atoms can be flat, and the 2 atoms can stick to each other this way by connecting with another side this way. So they could be a triangle, or they can be in squares, or they can be hexagons, they can be in lots of different shapes. And the way they bond is the difference, like carbon, right? It can be soot or it can be a diamond. I mean, a gigantic difference in terms of physical properties, made out of the same, whatever, C, C atom. You know, I don't know what the electrons, I guess carbon has, I mean, I'm thinking it has 8 in the, but, you know, that would be the same as oxygen then. You know, electrons, and it's fine. So the point is that, yes, the chemistry is huge, but it's physics, right? But that's, yeah, again, that's taken my subject a little further than I want to go. But it's hugely important in terms of understanding properties of things, is to understand how they bond to each other, the atoms themselves. And, you know, just understanding how similar atoms, that is, one water molecule combines with another water molecule, like for ice, they combine in such a way as they create a bunch of empty spaces. So they combine in groups, okay? So they're not like single atoms. They're like a group of atoms and another group of atoms. So they're in domains, essentially, and those domains end up meaning that the water expands as it becomes more rigid, cold, less moving. The atoms don't move as much. You know, understanding, well, anyway, getting into this whole thing of, I said, you know, and I think the chemistry argument is huge in understanding that the current theory that electrons are spinning around in the atoms, I think, is just nonsense. And I think chemistry kind of demonstrates that, because none of this chemistry would make any sense if the electrons are mobile. But anyway, that's a whole other subject. Did you know that the current model fails to explain this elasticity? Well, you say it does. I don't think it does at all fail. Clearly, this is about how the molecules, the individual atoms, connect to each other to create different shapes of the molecular form. So molecular water can have different geometric shapes. The domains of water can have different shapes. And certainly the outside molecules will always be H2O, but the interior molecules will be something like, you know, one oxygen will have 4 hydrogens connected to it. So it's going to be, you know, O, it'll be H4O, yeah, you know. So I'm just saying, it's not even that it's that complex. I'm just saying this, there's a subtlety to understanding that the surface of stuff will be its raw form, like the surface molecules on a diamond. The trick is that the carbon atoms have all you can say is it seems likely that carbon atoms are flat. You know, just because of the way they connect, that they're obviously on a diamond, they're not leaving any connecting surface. You know, and that's why diamonds are almost impervious to everything. They will interact with nothing. So it's almost like the atom has to be almost flat to explain why, number one, they're so faceted, and, you know, especially in graphite. So in the carbon, in the simpler form of like graphite, you know, the whole point of making it slick is that it's a bunch of little flat surfaces sliding over each other that have no friction. And they have no friction because they're all proton heavy and they're repelling each other. You know, there's no bonding elements. Well, anyway, it gets complicated. The reason they can't explain it is because it never occurred to them that the polar force is not static. So again, this polar force doesn't say much to me, you know, beyond saying, okay, the native state of hydrogen. Okay, so hydrogen has some bonding desire, and that's why the 2 hydrogens end up on one side of the oxygen. But then you still have to explain why nothing connects to the other side of the oxygen atom. And oxidizers are just the oxygen is just saying, I will bond with almost anything. Oxygen just loves to connect to everything in the universe. But anyway, let's see. And it'll be a whole side of the oxygen that's just saying, stick to me. But anyway, never occurred to them the polar force is not static but highly variable. So I don't think the force is variable. I think the way it starts to form a crystal is variable. And it's really just about growing whatever the seed form is. So when something starts to cool and the atoms themselves can now rub up against each other, you know, get more comfortable with each other, and they start to stick because they get, you know, close enough to stick, because they don't have a bunch of infrared radiation pushing them apart, then pushing their electrons apart. Yeah, so then they can form into shapes. And it just kind of depends on what the seed shape is, will decide the later shape. But it all ends up just being a kind of idea of everything just starts sticking to whatever the original function was, and so the original shape ends up being the later shape because it all just kind of randomly sticks. There's a random amount of interactions, and so if it starts off round, it'll just keep being round because there's going to be as much stuff sticking this way as there is this way or this way, so it kind of keeps its shape. But if it starts being too close to something else, well, then the shape could end up being kind of strange. And then if there's three of those things, then the shape gets a little stranger. Yeah, you know. Well, anyway. But highly variable, and that proximity of H2O molecules to one another is the mechanism thereof. Well, obviously all molecules start sticking to each other. All atoms start sticking to each other when you cool them. You know, pretty much all atoms. Do you yourself have a preferred explanation for the elasticity of water? Let's see. I guess I would say that the original water molecule, the bonds between the original first two hydrogen atoms, is clearly stronger than any subsequent attachments. So obviously it's misshapen the oxygen. So when the two hydrogens stick to the oxygen, they misshape the rest of the oxygen part of the molecule. And that misshapenness is what makes any other attachments weaker than the original oxygen molecule. So they break apart as individual water molecules instead of breaking apart into oxygen and hydrogen. And that's kind of happens with all. I mean, it's easier to... I mean, two gold molecules are fairly easy to separate from each other. See, we're talking about a compound, water, so it's hard to compare it to an element. So you have to kind of compare it to other compounds. And there's so many compounds, you know, that do weird things that, you know, what's the point, right? Because I could, if I knew a lot about chemistry, I could say, well, sulfuric acid does this, or, you know, hydrochloric blah 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 does this, or some, you know, there's probably lots of chemicals that do some weird shit. It's just that they're not as abundant as water. You know, so they're not worth talking about because nobody knows they exist. So, but anyway, valid enough point, I suppose, and such. Alright, so let's just do this. I thought this was an interesting title, The Impossibility of Perpetual Motion Machines. Right? So, I mean, that's sort of an interesting subject. Because I would argue the only thing that has perpetual motion is the force itself, the photons. And they never die. And so they just get converted from ultraviolet light goes in, it's converted essentially into infrared, photons that might still be bouncing around inside the material, and the infrared might pop out, or it might be even in X-rays inside the material, and then it comes out. When it finally leaves, it's emitted by an electron, or it's emitted, by the reaction between two electrons. But whatever, it leaves as still radiation. And if gravity is the same kind of radiation, then it can also leave as gravity. But it leaves as something going the speed of light, and so you never lose the quanta of momentum. And but the interesting part is that you can create things that do have perpetual motion, in the sense that you can make matter move through space as if it has perpetual motion, even though you could throw me into space and I might just keep drifting in space at the same speed forever. And but that's happening because I have trapped inside of me enough perpetual motion to do that. Enough more little bits going one way than going the other way. But there's no way to tap that as energy. So lots of things can have perpetual motion, but the idea of using it as a machine, that is, the idea of you tying a rope to it and being pulled by it, well, you can't do that. Because as soon as you do that, you're applying another force, which is eliminating the imbalance, so you're sucking the energy out of the thing. So it's no longer perpetual, because you're applying a friction, applying a drain. You're draining the imbalance. So there's nothing you can create that has a constant source of imbalance. That you can't do. You can compress a spring, and then you'll get back what you put in. But you only get back what you put in. Could have said that probably better, but it's a pretty simple argument. But I mean, the idea that there's perpetual motion is a reality. It's just you can't gain anything from it. You can't lasso it and steal its energy. Not wrong way to say it, because we can. We can lasso photons coming from the sun. Now they have potential energy, but the point is the sun that's the source of them, well, yeah, that doesn't have potential number of photons to give, so it will run out eventually. So we can steal energy that was produced, that itself is perpetual motion, but there has to be a perpetual source. So I guess that's the key word. There's no source of perpetual motion. There's only the original universe. Yeah. But it's kind of a bold statement, right? The impossibility of perpetual motion. That's kind of stupid.
Thanks to CuriosityStream for supporting PBS.
Clearly photons have perpetual motion, and clearly material forms can be configured in such a way as they have an engine that is perpetual. They have trapped the perpetual motion in one direction more than the other direction, and they will continue to move in that direction perpetually. Is they trapped perpetual motion.
Digital studios. Bad ideas come and go in physics, but there's one bit of nonsense that is perhaps more persistent than all of the others.
No, I think your whole theory, so again, this is just so arrogant from people who believe in dark matter, entangled particles, all kinds of wooey Huygens, multiverses. I mean, I'll pick on their silly ideas and not pay any attention to your own.
Perpetual motion machine.
So again, the idea of the machine idea, right? That we can manufacture something that is perpetually creates imbalance. It can't do that. We can't create the imbalance. The imbalance has to be created by, that's a good way to say it. It was in the original universe. The fact that the original universe has energy going this way and has energy going this way. but we can't make the imbalance. We can only take advantages of imbalances the universe has already created.
No working perpetual.
I mean, it's like taking advantage of the fact that the Earth is pushing from the sun's radiation. It heats the water rises in the atmosphere, and we can take advantage of it falling down. But that's it. We're just taking advantage of something else that compressed the spring.
Perpetual motion machine has ever been experimentally verified. All break the laws of thermodynamics. In fact, we classify them based on which law of thermodynamics they break. We have perpetual motion machines of the first kind. They violate energy conservation. They pump more energy out than they need to keep running. This includes most of the historical devices. Then there are machines of the second kind. They're a bit more subtle in their wrongness because they break the second law of thermodynamics, extracting energy by reversing entropy.
See, what's like gravity is you can call it a conservative force, and you can even call it a closed system. So it doesn't have to be in the rest of the universe in the sense that whatever goes in, you'll lose all of the speed you get from it by trying to leave it. So in that sense, you can't hit net, can't do anything. It's a net nothing.
Many modern free energy devices fall into that category. Now, the best modern designs are by you. They are answers to our recent challenge question, which we'll get to in the end. But first, let's take a look at examples of what other people came up with. This will be a fun little journey through some pretty terrible science.
So what's the point of this? Yeah, so you're just going to go over the same crap that we've seen over and over and over again of machines that, well, on the face of it, look like it might be able to work, but, oh, there's the flaw, or there's the flaw. Where there's too much friction, there's too something.
Designing your own perpetual motion machine became quite the craze from the Middle Ages through the Renaissance.
See, but a lot of them aren't perpetual motion machines. A lot of them are efforts to do what we do with hydroelectric, which is take advantage of the one direction of the imbalance, one part of a cycle. So you could argue that gravity, we're sitting in gravity, and in a sense we just keep thinking there could be a cycle we can take advantage of, that we can create our own small version of the thermal cycle in the atmosphere. So the atmosphere sends the water up, we take advantage hydroelectric of it going down. That cycle seems like, well, why can't I make a small version of that? Not using water molecules, but using some other mechanism where I can take advantage of the fact that some part of nature will do the pushing up, okay, something will push it up, and I can take advantage of the going down. So you can almost argue that the little swan thing that dips its nose in the water is a perpetual motion machine. But the point is that the amount of energy it produces is so small, that is the amount of energy in its cycle, that you can't use it as a practical perpetual energy device because the evaporation takes way too long on a big scale, and to pull any of the energy out, there's way too much friction, and you're not going to get anything back from it. The radiometer, the little spinning thing, it's a perpetual motion machine in a sense that the sunlight is perpetual, and it's just trying to do the same thing. So it does have a kind of perpetual motion because it has a perpetual source of photons. Perpetual in the sense of however long the sun lasts. Let's see, how else could you... I guess it's just in the way the words are used and not understanding that there is perpetual momentum in the universe in the form of energy. The energy is perpetual, it can't be destroyed. It goes into things, it moves around them, cycles through them like fish. It's a real fish that are in systems, and they have real momentum in a direction when they go into a system. And it's just a fact that they had that direction, that momentum.
First well-documented design was from the 12th century. Bhaskara's wheel, named after the Indian mathematician, it was embedded with these tubes of mercury that would flow back and forth as the wheel turned. Other types of overbalanced wheels followed through the Renaissance and worked on the same principle. Basically,
I don't think that's hardly the first one. I mean, mercury, come on, there was probably some guy who did one with sticks and stones. But okay.
the shift in the centre of gravity of the spokes on one side should drive the wheel around. There were also designs that employed the magical seeming lodestones, magnets. For example, this ramp in which a ball is pulled to the top of a ramp by a magnet before falling through a hole and rolling to the bottom again. Then there were the self-pumping water wheels or the self-blowing windmills. None of these machines actually worked. In every case, you can find a subtle bit of physics that the design...
Yeah, it's exactly what I just said, right? You can find some little gimmick that says, oh, damn, it won't work for that reason. Shucks. But again, we see it working. So if I could build a small-scale little environment where the Earth's heat rose the water and I could just take advantage of the water falling, that would be successful in the sense of calling it perpetual, in the sense that as long as the Earth exists and the sun exists, I could keep my machine running and I wouldn't have to feed it anything because it would be running off of sunlight.
Is overlooked. The overbalanced wheel pushes masses outwards on one side, but at the same time increases the separation between those masses so that the moment of inertia is unchanged. A magnet strong enough to pull a ball up an incline will also prevent it from falling through that hole. Losses due to friction mean that water or wind driving a mill could never produce enough energy to fully complete the cycle. Close, but no perpetually burning cigar. Now, to be fair to the people working during the Middle Ages and the Renaissance, the law of conservation of energy hadn't been discovered yet. Thus the proliferation of first-type machines.
Again, there's no law. Okay, the law is just a recognition of the fact that there's some elemental limitation that prevents it. So it's not like we discovered that limitation. We just discovered the fact that there is a limitation. Because again, to know the limitation, you'd have to know exactly what photons are. You'd have to know exactly what their momentum is. And I don't think these people have any clue. And I certainly don't think they have a clue about something more complicated like an electron.
That could generate more energy than they used. But absolute proof of their non-viability by the discovery of the first law of thermodynamics in the 18th century did not end the craze. Inventors just graduated to instead breaking the second law of thermodynamics. To review, the second law states that entropy can never decrease over time. Or in other words, energy will tend to spread itself out as evenly as possible, to a state of maximum entropy. All machines work by...
So again, I think these entropy arguments are kind of just bogus in the sense that we know these are all closed systems. So anybody who's going to come up with a perpetual motion machine, it's always going to be in the context of Earth's circumstances, which is gravity and an atmosphere and lots of stuff. And so as long as they can make the device work on the surface of the Earth without some obvious argument about how they're taking advantage of sunlight or something. But I'm just saying that, the energy source is always going to be kind of obvious, even if they made one that was able to somehow... See, gravity, you just can't... Gravity is more than just thermodynamics, right? The argument about gravity isn't a thermodynamic argument. It's the same principle in the sense that it takes as much energy to go up as it does that gravity provides you going down.
By riding this flow of energy as it redistributes itself. Machines of the second kind claim to be able to tap reservoirs of energy that are already evenly spread, effectively reversing the growth of entropy. Now, before we get to second law violating modern perpetual motion machines, let's take a look at some actually interesting ideas that illustrate the limit of the second law. First up, the Brownian ratchet. It goes like this. A paddle wheel immersed in a gas is connected to a cog with a latch that only lets it turn in one direction. Individual gas particles are moving around with random or Brownian motion. When one hits the wheel in one direction...
Right, so one direction it can move, the other direction it can't move in. So it only takes the motion that randomly is always uneven. So it's taking advantage of the fact that it wobbles up and then it wobbles down and it wobbles up and it wobbles down. And so it's basically just saying we only move the wheel on the upstroke and we never move the wheel on the downstroke. So let's see how he defeats that. I mean, it's just going to be a friction argument, the bottom line. It's not that in principle it couldn't work. It's that there's too much friction in the system, so it can't work. So he's probably going to blame the friction of the lever as absorbing all the energy you got from the Brownian motion.
The cog turns, but in the other direction, the rotation is blocked. That sounds plausible, and it actually works, but only if the chamber containing the cog is at a lower temperature. If it's at the same temperature, then the cog is as likely to be pushed back when the latch raises. Richard Feynman himself demonstrated it.
Well, that isn't even true, because obviously you can put it in a form where the matter isn't as easily accessed. It's denser, has less surface area. So the more surface area would mean, oh yeah, well, it still gets dicey, right? Well, anyway.
This mathematically. This is actually a specific example of a Maxwell's demon device, an entropy reversing thought experiment that we've discussed before. With no energy or temperature gradient, no energy can be extracted. In fact, there's an absolute limit on the amount of energy that can be extracted based on the difference in temperature. That limit is defined by the most important, perhaps the only important, perpetual motion system ever conceived, the Carnot cycle. In the early 19th century, Sadi Carnot described the most efficient possible engine. It's a sequence of expansion and contraction of gas in a piston chamber that will provide the maximum possible energy as heat flows between reservoirs of different temperature. Critically, the Carnot cycle is reversible. Drive the piston in reverse with exactly the same amount of energy, and it'll transfer energy from cold to hot. In principle, a Carnot cycle could extract energy from a temperature gradient and then pump it back in again, making it a candidate perpetual motion machine. But even in this most...
That one doesn't even seem that impressive, just because obviously you have to be able to change, you have to be able to move things that have a temperature change, so you have to move an awful lot of matter. So that sounds kind of silly.
Most ideal case, the ratio of energy in to energy out is exactly unity. No extra energy is extracted. The Carnot cycle is, in principle, a perpetual motion process, but it doesn't break any laws of thermodynamics, so it's not the first or second kind. In fact, it's the third kind. These are perpetual motion machines that do not attempt to generate energy. They just keep themselves running forever. Sounds okay, right? After all, Newton tells us that an object in motion tends to remain in motion unless acted upon by an outside force. So remove all outside forces, remove all friction, all energy losses of any kind, and surely any machine can tick on forever.
Well, you still have to have the energy source, so you're still taking advantage of some imbalance that was created by some thermal imbalance. You can't have a velocity unless somehow you've found some method to trap momentum in one direction. So you're still stuck with that problem. That momentum had to come from something.
Indeed, there are ideal systems that, from pure classical principles, should run forever, like a perfect Carnot engine, or a frictionless wheel with or without magnets or mercury tubes, or a planet orbiting a star. Just eliminate any leakage of energy. But that's not just an engineering challenge, it's fundamentally impossible. Actually, quantum mechanics forbids this. Due to the...
Oh, what a pile of crap that is. Quantum mechanics forbids this.
The intrinsic randomness of all particles, as expressed by the Heisenberg uncertainty principle...
Yeah, so just more a made-up principle that doesn't really exist in any sense whatsoever. It's just an observed fact that we can't avoid the fact that the universe is random. So it has nothing to do with quantum mechanics saying the universe is random. We already can say the universe is. We don't need Heisenberg to tell us, oh, the universe is moving in one direction or not moving in one direction, has a bias in a direction. We wouldn't know anyway. We can only live from the surface of the Earth. We can only approximate a vacuum when we can't make one. We can only understand it synthetically. So I'm just saying we can't even prove that anyway, because we don't have an environment that allows us to prove the whole universe is moving 50 miles an hour that way.
Everything moves. Internal parts always vibrate, guaranteeing some friction and internal heat. Even if that heat is recaptured, the outer walls of even the most carefully isolated system must radiate, slowly leaking energy. And then, of course, there's the gravitational radiation that will slowly sap the perpetual motion of celestial systems. The best case scenario.
So, again, this is sort of a denial. So what are you going to say? The point is if I throw a wrench in space, there's no theory that says the wrench stops. All right, so in a sense, the wrench has perpetual motion. I just can't steal it. I can't take that energy, but in one-time event. It won't keep pushing on the rope. If I tie a rope to it and I pull, that's it. It's done. It stops. It doesn't keep moving, so I can't gain more and more from it. I can only gain one pull, and that's it. I can stop it and gain the force effect. I can have it hit my hand and stop, and I get that one-time force, and that's all I'm going to get. There's no continuation of the energy. But clearly, when it's moving through space, it does have perpetual motion. So it's just silly to say it's not a perpetual motion machine. There's a perpetual motion machine inside the matter when it's moving through space. And the perpetual motion is created by the atoms that have trapped more momentum moving one way than they've trapped going the other way.
For a perpetual motion machine of the third kind is a very, very slow wind down to stillness. Now that we've reviewed the three types of possible wrongness in perpetual motion machines, let's look at some of the modern proposals. Most look like the ancient predecessors, often lots of wheels with lots of magnets, somehow powering their own motion and producing extra energy besides. These are often referred to as over-unity devices. The ratio of energy out to energy in is greater than 1. And that name was actually coined by patent offices, which in the US and the UK refused to review devices claiming over-unity energy production. And understandably, it eliminates 50% of their crank submissions. Now, the purveyors of over-unity devices typically do not claim to have created perpetual motion devices of the first kind. They have various explanations for how they don't violate conservation of energy. However, most end up shifting their device to the second kind of perpetual motion. They violate the second law of thermodynamics by extracting energy where there is no energy gradient. One popular source of free energy is the zero-point energy of the quantum vacuum, and it's the most fun to debunk. I'm going to have to refer you to our entire playlist on the quantum vacuum for the physics.
Oh, whatever, the quantum vacuum, just more crap.
The important point is that any energy of the vacuum is exactly the same everywhere. It has no...
There's no vacuum energy. It's just a retarded statement. Evacuate the photons and there's no energy. Period.
No energy gradient, so it isn't accessible as an energy source. Now, it may be possible to create an energy gradient, for example, with the Casimir effect, in which parallel plates are pulled together by lowering the zero-point energy in between.
So this is their bullshit interpretation of Casimir effect, which the Casimir effect really just has to do with the fact that when you bring the two plates together, the electrons obviously repel each other. There's more electrons on the surface, and one side, okay, one of the sides has to say, I'm going to go proton heavy, and one side goes electron heavy, and it's just an obligation of charge. So one side has to win the battle. Both sides won't win. One side is going to have to be where the electrons push in and the protons push out for the two sides to be able to move any closer together. So as they're moving towards each other, they're both repelling on each other's electrons and trying to push them past the protons. One side is going to do that a little bit more effectively. That is, one side, the electrons are going to go more deeper, and the proton's going to start sticking out. And as soon as that happens, that side's going to go proton heavy fast. And when it goes proton heavy, the other side's going to go all the way electron heavy. And so it just has to do with charge. It doesn't have anything to do with any vacuum energy.
Between them. But doing so repeatedly in an engine cycle takes at least as much energy as it produces. The best you have is a perpetual motion machine of the third kind.
There's no... it's impossible to gain perpetual motion from charge. So that's, again, just silly. I mean, those are all closed systems. And the the closed system has the like, again, it takes as much energy to pull electrons. It takes as much energy to, you only get back from the spring what you put into the spring. So when you push two electrons into each other, the amount of energy it takes to push them into each other is the same as the energy you get out from their expansion.
Most modern perpetual motion builders aren't so technical. In fact, the worst of them wouldn't have physics or engineering chops to build a decent overbalance wheel. They rely more on pseudo-physics speak. 0-point mag-grav plasma torus vibrations sounds fancy.
Yeah, you people are so full of bullshit speak. I mean, your information crap, your all these bullshit terms you throw out here. I mean, your quantum color, your spin notions that aren't really spin. I mean, you're so full of crap.
But are typically less good at generating free energy than they are at directing you to the donate button or selling you a telluric field wellness crystal. Okay.
Oh yeah, like you aren't selling anything, right? Like there aren't ads all over your videos, right? You know, in the sense that the whole end of this video will be some ad for whatever, whatever they call that stupid learning program.
And half with the nonsense. Let's get to the challenge question, in which I asked you to come up with a perpetual motion machine based on the funky notion of negative mass. According to some interpretations...
Alright, so I'm not even going to play this, right? This negative mass thing is just fucking idiotic. So yeah, fuck it. Too stupid. Way too stupid. Waste of people's time. So he's selling whatever this is. Stream or something, some bullshit. So just, you know, what a fucking hypocrite. You know, like this propaganda is any better than any other sourced propaganda. People with agendas. That's all this is. Agenda fucking science. Ugh. Disgusting. Alright, so till the next time and such. But, you know, it's an interesting subject in the sense of just understanding, I mean, only through this whole process of looking at all these videos, watching all these, especially I love the old ones, the 60s stuff is just so interesting. You know, just understanding how all the energy is in the form of little bits moving the speed of light forever. And that's it. And that's the thermodynamic reality. And it's always a little bit, a photon essentially, goes in a form of magnetism or gravity or whatever the form is, and it can come out as a visible light photon or it can come out as some other kind of energy. But it's always going to be, while it's held by any system, that system will have an imbalance. So whatever goes into the system, if the system holds more stuff that came in this way, then the system is going to move that way. And that's all the electrons and protons are doing. It's providing a system that will move while it holds energy. Okay. Perpetual motion, while it traps fish. Yeah. That never stop and never die. Alright, anyway. Till the next time and such. And so forth and whatnot.